Historically, a camera was really just an eye, right? It was entirely dependent on a human operator well, to act as the brain.
Yeah, exactly. But that's changing fast.
Right, because this new generation of broadcast gear is like bringing its own brain to the gig. So today we are doing a deep dive into the surprisingly automated world of high-end broadcast equipment.
And we are looking specifically at the spec sheet for the Bolin Technology R9-420N.
Yeah, a single device that carries a $4,695 price tag, which is, well, it's a lot.
It is. But when you look at the specs, you see this massive blur between traditional recording devices and essentially AI-driven broadcast robots.
Right, which fundamentally changes how the media you consume every day is actually captured.
Yeah, the shift here is really about who, or honestly what, is directing the shot. Because the optical baseline is already super high, with a Sony 4K image sensor and a 20x optical zoom.
Sure.
But the standout mechanism is actually the AI-powered facial analytics engine.
Okay, so what does that actually do in practice?
Well, it's designed to lock onto faces and keep the focus and exposure perfect, even in really complex shifting lighting situations.
I mean, that sounds like having a highly caffeinated wedding photographer who just never loses focus.
That's actually a pretty good way to put it, yeah.
But wait, we already have face tracking on our smartphones, right?
Yeah.
I am assuming this AI has to do a lot more heavy lifting to handle live, unpredictable broadcast environments instead of just, faking a depth of field blur.
Oh, absolutely.
Yeah.
I mean, the stakes are entirely different here. A smartphone just isolates a face for a static photo or maybe a highly controlled short video clip.
Right, right.
But in a live broadcast, subjects are constantly moving, stage lights are flashing all over the place, and there is no take two.
Yeah, you can't exactly yell cut during a live keynote.
Exactly.
Okay.
So the camera's AI analyzes the video feed frame by frame in real time, and it instantly adjusts the mechanics of the lens to ensure that the face is never lost in the shadows.
Wow.
Yeah, it's basically making thousands of micro decisions a second.
And because it's a PTZ camera, it physically tracks the subject too, right? Like moving 340 degrees on the pan and 120 on the tilt.
Right, and the crazy part is it's doing all of this while constantly broadcasting its exact coordinates using what's called the FREED protocol.
FREED, right. What exactly is that?
So FREED is this data protocol that outputs the camera's precise position, so pan, tilt, and zoom data in three-dimensional space over the network,
Okay.
which allows it to integrate flawlessly with augmented reality and virtual reality setups.
Oh, so if you have a real person in a green screen studio and the camera pans left.
The FREED data tells the virtual background to pan left at the exact same speed and angle. It literally marries the physical camera movement to the virtual world.
Wait, I have to push back on this level of automation for a second because
Yeah.
human operators do way more than just pan and tilt. They anticipate the action, like predicting when a speaker is about to walk across the stage just based on their body language. Can an algorithm using FREED actually anticipate, or is it just reacting really, really fast? I mean, does this make the human camera operator obsolete in these virtual setups?
Well, no, humans are absolutely still needed to set the parameters, design the shots, and like you said, anticipate the emotional beats of a performance.
Right, the artistry of it.
Exactly. But for the repetitive, highly technical tracking required to keep a physical subject perfectly aligned with a VR background, I mean, the math is just too complex and fast for human hands to match reliably.
So the role just changes.
Yeah, the human role shifts from a hands-on mechanical operator to more of an overseer.
But capturing that perfectly tracked 4K shot is, well, it's completely useless if it gets bottlenecked on the way to the switcher.
Oh, for sure.
Which brings us to how this camera distributes the data. It features this thing called true tri-output, right? Pushing out 12G SDI, HDMI 2.0, and IP, or NDI, streams simultaneously and completely independently.
Yeah, it's a massive feature.
It's like a master interpreter translating a speech into 3 different languages at the exact same time, but doing it while running a sprint, because it's rendering uncompressed 4K local display and compressed network IP streams with literally 0 latency. But my question is, why not just use a standard downstream converter rack like we always have?
Well, to push uncompressed 4K video, you need massive bandwidth. That's what the 12G SDI connection handles, sending that heavy-duty feed to the main production switcher.
Right.
But simultaneously encoding that exact same 4K feed into a compressed NDI stream for, say, a local network live stream requires serious onboard processing power, so there isn't a lag between the two.
Ah, okay.
Historically, yeah, you would need a rack full of expensive, really hot converter boxes to do that. But by outputting all three natively from the camera head itself, it essentially acts as the central nervous system for the broadcast.
Which eliminates those external points of failure.
Exactly.
So when you watch a live event today, you aren't just looking through good glass anymore. You're really looking through an entire ecosystem of 4K optics, real-time AI tracking, VR readiness, and like universal connectivity.
Yeah, it truly is a marvel of onboard processing that operates entirely behind the scenes just to deliver this flawless visual experience.
It really is. And as protocols like Freed make these cameras increasingly autonomous, you really have to wonder, will the future of live events be directed entirely by mathematical algorithms rather than human vision?
It's a fascinating question.
Definitely something to mull over the next time you see a perfect, fluid camera pan across your screen.